All right, in part C, we're asked to find and interpret this integral, the integral from 0 to 2, absolute value v of t dt. So that's the integral from 0 to 2 of the absolute value of 3t squared minus 2t minus 1 dt. Now, the thing about absolute value is that the absolute value of 3t squared minus 2t minus 1 is going to be one of two things. If 3t squared minus 2t minus 1 is bigger than or equal to 0, the absolute value is going to leave it alone. If, on the other hand, 3t squared minus 2t minus 1 is negative, the absolute value is going to return the opposite of that to make it positive. So what we need to do is figure out if this function, if v of t, the 3t squared minus 2t minus 1, changes sign somewhere in the interval of 0 to 2. Physically, that means that, is the particle changing direction? We know it initially is heading downwards. On the interval from 0 to 2, does it ever turn around and start heading upwards? So really what I need to do is find a sign diagram for the velocity. So I need a sign diagram for that function to see if it's going to switch. So let's build a sign diagram for v of t. So how do I get a sign diagram? I need to know where this thing is going to be changing signs. From positive to negative, that could happen at one of two different kinds of places. If there's a place not in the domain, it could happen. It could also happen where we have a 0. Since this is defined for all values of t, we'll just go ahead and set it equal to 0. So I get 3t squared minus 2t minus 1 is 0. And I attempt to factor that. And if I factor it 3t plus 1t minus 1, that works. So I get t equals negative 1/3, and then t equals 1. So I'm going to use these and make a sign diagram. Well, if I look here, I'm integrating from 0 to 2. So that's the interval I really care about. So I can start and stop my sign diagram at 0 and 2. And the only one of those values in there that I care about, the critical values, would be t equals 1. T equals negative 1/3 over here, I don't really care about that. So I pick a test value, say 1/2, and say 3/2, and I look at v of a half and see what sign that works out to be. So v of t is 3t squared minus 2t minus 1. If I plug a half into that, I'm going to get a half squared as a fourth, so that gives me 3/4. A half times 2 is 1 minus 1. That's going to give me a negative number. So v of t is always negative on that part of the interval. If I plug 3/2 in, 3/2 squared is 9/4 times 3 is 27/4. Minus 2 times 3/2, 3 minus 1. So I get 27/4 minus 4. That's going to be a positive number. There. So in fact it does switch at t equals 1. The velocity is negative for the first second. That means the particle or the object's heading downwards. Then at 1 it changes its mind and then starts heading back up. And so what I need to do is break this integral up at t equals 1 because the function's going to change. I can do that using the additive interval property. I can go from 0 to 1 of the function and then add to that the integral from 1 to 2. Okay, so what have we learned here? We've learned that the absolute value of 3t squared minus 2t minus 1 is going to be what? Well, on the part from 0 to 1, we found that 3t squared minus 2t minus 1 is negative. So when I take the absolute value of that, I'm going to have the opposite of that. But when t is between 1 and 2, we learn that 3t squared minus 2t is positive, which means that I'm just going to have the original function. Okay? So, my integral then, from 0 to 2, of the absolute value of 3t squared minus 2t minus 1 dt is the integral from 0 to 1 of this guy, dt, plus the integral from 1 to 2 of this guy. Oops. Okay, so to evaluate the first integral, I apply the fundamental theorem of calculus. The integrand here is the exact opposite of my original integrand, so my antiderivative is going to be the exact opposite of it too because of the constant multiple rule. So what am I going to get out of this for my antiderivative? I'll get minus t cubed plus t squared plus t, evaluated from t equals 0 to t equals 1, plus, and then this is the same integrand I had before, so my antiderivative is the same, t cubed minus t squared minus t from t equals 1 to t equals 2. I substitute this in. When I plug in t equals 1, I get negative 1 cubed plus 1 squared plus 1 minus negative 0 cubed plus 0 squared plus 0. And I'm adding to that, plug in t equals 2, 2 cubed oops, 2 cubed minus 2 squared minus 2 I'm going to match my grouping symbols up here. Minus, plug in 1. 1 cubed minus 1 squared minus 1. Now when you go to evaluate this, remember the power comes before the negative. So I take 1 cubed, which is 1. Take the opposite of that, that's negative 1. Negative 1 plus 1 is 0, plus 1 is 1. This is a bunch of zeros. So I get a 1 out of that. Here I get 8 minus 4 minus 2, which is 2, minus 1 minus 1 minus 1, which is negative 1. So 2 minus negative 1 is 3. So my answer is 1 plus 3, which is 4. So the integral from 0 to 2 of the absolute value of v of t dt is 4. And now the question is, what's that represent in terms of the object and its motion? Well, as we discussed in class, v of t is the velocity of the object. That gives you the speed and the direction. The direction is either plus or minus. So when I take the absolute value of that velocity, I'm getting just the speed. The integral of the speed gives you the total distance traveled. Since we're going from t equals 0, which is the start of the motion, to 2 seconds later, we can say that over the course of the first 2 seconds, the object has traveled a total of 4, in this case, meters. So that'll do it for part C.